Good morning, students. Today we will try to see the flow boiling regime. In the previous lecture series, we have seen the pool boiling regime. In this given class, we will try to see the regions expected in the flow boiling here. So, flow or forced convection boiling may occur when a liquid is forced to a channel or over a surface which is maintained at a temperature higher than the saturation temperature of the liquid. There are numerous applications of flow boiling, the design of steam generators or for nuclear power plants and space power plants here. So the mechanism and hydrodynamics of flow boiling are much more complex than in the pool boiling because the bubble growth and separation are strongly affected by the flow velocity here. And also in flow boiling, it is a two-phase mixture of liquid and its vapor here. And we have two types of boiling with respect to the flow bomb. One is the external flow boiling, another one is the internal flow boiling. So this is a typical flow regime uh, uh, encountered in flow boiling in a tube under the forced convection here. So two phases are involved in the flow boiling here. We will try to see the significance of each of the regions which is formed as the fluid flows along the heated tube here or the hot surface here. So we have different types of regions, namely the forced convection mode, then the bubbly flow, slug flow, annular flow, transition flow, mist flow, and finally the forced convection dominates the process here. So you could see the correspondingly there is an increase or drop in heat transfer. You could see as the flow progresses towards the other end of the tube here. The heat transfer to the subcooled liquid at entry is by forced convection. This regime continues until boiling starts here. Then the heat transfer coefficient in the boiling region is suddenly increased. In this boiling region, the bubbles appear on the heated surface, grow and are carried into the main stream of the liquid so that a bubbly flow regime prevails for some length of the tube here. So as the volume fraction of the vapor increases, the individual bubbles coalesces and plugs and or slugs of vapors are formed. This regime is called as the slug flow regime here, as you could see in this second one next to the bubbly flow here. As the vapor quality is increased, the flow becomes annular with a thin liquid layer on the wall and a vapor core here. So it will be a two-phase mixture. So the vapor velocity is much higher than that of the liquid here. The heat transfer coefficients remain high as long as the liquid film wets the wall. Eventually, dry spots appears on the wall and the heat transfer coefficient drops sharply. This region is called as the transition region from the annular flow to the mist or fog flow. Burnout sometimes occurs at this transition because a liquid film of high thermal conductivity is replaced by a low thermal conductivity vapor at the wall. See the dry spots, the dry spots continue to expand until all the remaining liquid is in the form of fine droplets in the water. This is called as the mist flow regime, as you could see at the last stage of the boiling regime here. There is a little change in the heat transfer coefficient through the mist flow regime, which persists until the vapor quality reaches the 100% vapor here. Beyond this point, the vapor is superheated by forced convection from the surface. So due to the complex nature of the boiling process, so no general correlation as to predict the heat transfer coefficient for all the various boiling regimes takes place in the tube has to be formulated, as no general correlation is generally available for the flow boiling process. It's a very complicated process in comparison to the uh, pool boiling regime here. So we could see the different uh, regimes here, starting from the bubbly region to slug region, annular region, transition region, mixed region, and finally the conversion dominates the process here. In all the regions, there you could see a sharp increase or drop in heat transfer coefficient here. So this is what the various regimes as what we could see in the flow boiling here. The references taken for this presentation is the following two references. We will try to see the